In this problem, a bank account grows at 10% annually, but money is being withdrawn continuously at a rate of $10,000 per year. Now, in real life, money doesn't just leak from an account at a continuous rate, but that's the assumption that we'll make for this problem. We're asked to write a model that gives the money m at time t and then plot the associated direction field. Okay? And we will let m be in thousands, just so that our graph is a little simpler. All right, so let's start off the rate of change of the amount of money, so dm over dt. Once again, m is in thousands of dollars and t is in years. We're talking about annual growth. All right, so we know that the rate of change of money, well, it's the rate that the money comes in, and we subtract off the rate that the money goes out. All right, how fast is money coming in? Well, we know that it's growing 10% annually. 10% of what? Well, 10% of the amount that's there. So I'm going to multiply 10% times the amount of money that I have. And then for the rate out, well, we're losing 10,000 per year, so it's at a continuous rate, although since m is in thousands, we're just going to subtract off 10. So there's our differential equation. dm over dt equals 0.10m minus 10. We are asked to plot the slope field, but before we do that, let's read this last question. Is there an equilibrium value of money where the money in the account is neither growing or shrinking? Well, if we're taking out 10,000 per year, but it's growing 10% each year, we might try a few values. What we'll find is that at 100,000, so when m equals 100 in this problem, then we would lose 10%, which would be 10,000, but then we would also, in interest, be gaining 10,000 per year, and those would just kind of cancel each other out. So there is an equilibrium value here. It's $100,000. So let's look at what the slope field would look like. We're using an online slope field plotter, and the link is included in the homework. All right, so I've typed in the equation, except in this case it uses x's and y's where we used m's and t's. So m becomes y, t becomes x, so we have 0.1 y minus 10. And I plotted it from 0 to 200 on both axes. And we look at this behavior. So I guess I could hide these three. We can get the exact slope at any of these points just by plugging in an x and a y coordinate. Although, notice we don't actually need any x coordinate here. It only depends on the y value. And that kind of makes sense. In this case, the amount of money that you have didn't depend on when you had it. It really just depended on what the starting value was. All right, so what do the solutions look like? Here are three of them. We got the equilibrium value at 100 or $100,000. That's line across the center. And that point A, we see the values climbing. So if we had more than $100,000, it would grow slowly at first, but then start growing faster and faster. And if we had less than $100,000, we would slowly start losing money and then lose it faster and faster. It wouldn't take long until we were broke.